Alright guys, welcome to Algebra 2. This is 2.2.4 and we're going to be talking about transforming things that are not functions today. But we're really going to focus on just non-functions in general for today, and then tomorrow we're going to worry about how we can transform them. So, to start off, I want you guys to go ahead and try out problem number 132. So do this without a calculator that includes Desmos, and see what you can do with it. Then once you're done, go ahead and come back here. Okay, so what you should notice is that on these ones we start to get more than one value for y for each of our x values which work, and that's the kind of thing which makes these non-functions, right? These would not pass that vertical line test. So I'm going to go ahead and do these on Desmos just to make it a little bit prettier. Right? So if you look at the first one, right, this is x equals y to the second. Okay, so we get this kind of graph here, right? It looks just like a parabola, but it's on its side, right? Which kind of makes sense, right? Because if I had y is equal to x to the second, then I would have a parabola that follows the y-axis. 5x equals y to the second, it's just a parabola that follows the x-axis, right? So if you were to plug in like x is 1, you would get y as a positive 1 or a negative 1, right? If you plug in x is 4, you get y as a positive 2 or a negative 2, right? If you plug in 9, you get 3 or negative 3, and you're going to get that same thing for every single possible value there, right? When you graphed the other one, which was x to the second plus y to the second plus 25, right? Yeah. Oops, equals, not plus. There you go. We get this. We get a circle, which hopefully you kind of found, right? So on this one, once again, if I plug in a bunch of values like 4, I get positive 3, negative 3, right? Or sorry, negative 4, and then same thing with positive 4, right? So I need doubles for almost every single thing that I plug in. The only times that I don't get doubles is at 5 and negative 5, because I get 0 there, right? So hopefully when you made your tables, you've found both of those different values. That's kind of why part B said, hey, look for times when you get more than one answer, because you're going to get more than one answer almost every single time here. So, and last thing let's talk about is what's the domain and the range of these functions? Well, this circle one, it's going to be from -5 to +5 for both the domain and the range because it's a circle. And then the parabola one, where we had x equals y to the second, that's just going to be a domain of 0 to infinity and a range of all real numbers because it goes up and down forever. So we have a good idea of what those are looking like now. So let me hop back over here. So the big difference between these and the ones we have used is that these are not functions. So we get more than one output for each of our particular inputs. That's the kind of the problem with them, but also what makes them unique. So the next problem here, oops, there we go, is going to ask us to rewrite these as if they were functions, okay? So that we can graph them. Now, the graphing calculators cannot graph things that are non-functions, but Desmos can. So I would normally have you do this on the TI calculators, but when you're at home, you don't really have access to these. So we're still going to go through the process of putting them into that form, which is likely similar to something you may have done when you were just trying to work on these on your own. So let's start off with x equals y squared. So if I want to put this in function form, I have to get that y by itself. So I have to square root both sides. And when I do that, I'll get y by itself is equal to, but then I have to have plus or minus the square root of x. Because whenever I'm the one who's putting that radical into the problem, I need to put that plus or minus on it, right? So then, that's it, right? And that's really two separate functions. That's y is equal to rad x, and y is equal to negative rad x. This is just a shorthand way of writing two different things that are almost identical. Now let's try the other one, right? If we have x squared plus y squared equals 25, I'm trying to get that y by itself, so I want to subtract off that x squared. Y squared equals 25 minus x squared. So then once again, I want to square root both sides. So then I'll get y by itself equals plus or minus the square root of 25 minus x squared. Now a big thing that people try to do is say, oh look, 25 is a perfect square, x squared is a perfect square, and say, oh, then this is 5 minus x. We can't do that because of that minus sign, right? If this was everything being multiplied, then we could do that and it would be awesome, right? But that negative is what's messing it up so that we can't do that radical through each part individually. You can only do that if stuff is being multiplied or divided. So that's it. There's my function there. But really this is two functions, right? It's y is equal to positive rad of 25 minus x squared, and it's y is equal to negative rad of 25 minus x squared, right? So each of these is made up of two separate functions. Now let's go ahead and graph those on Desmos. So I'm going to turn these ones off. So I said for my first one, it was y is equal to square root of x, and then y is equal to negative square root of x. And those give me the exact same graph as this one, right? This one is just these two combined, which is what we kind of found out because all we did was just change the form. So now we have two functions which together make this one non-function. Okay. Now let's try it for our circle, right? If I have y is equal to square root of 25 minus x squared, there's a half circle there, awesome. And then what if I do that same thing, but I put a negative in front? Now it gives me the other half of my circle. So we're able to write these non-functions using a series of functions if we need to, because oftentimes we like to have things in that y is equal to form, either because it makes it easier for us to graph, or it makes it a function which we can do more things with. So it kind of opens up our options for us. So for today, that is all we are going to do. Next time we are going to go on to the latter half, so day 2 of 224. So I will give you guys the homework. Here it is, 139 through 145, and then I will talk to you guys next time.